So we're good to go. Okay. So thanks everyone for taking the time to join us. I hope this is going to be a fun session. We're going to be reviewing a number of things that we have in the works, along with some of the things that are currently on the market when it comes to proving ground and some of the tools that we are building. To kind of start off, I thought it would be helpful to provide just a little bit of context on who we are and what we're about as a company. Proving Ground is a digital design agency that is based in the United States, and we help businesses become more data-driven, as well as leverage the potential of their digital tools. We've been fortunate enough to build many relationships with designers and builders and owners to realize many of these opportunities with data and their digital toolkit. Over the past 6 years, we've also been in a position to create a lot of tools that we believe streamline different production processes, explore design opportunities, analyze data, and all within a kind of a very kind of lean team. Proving Ground itself is only 5 people. We have 5 full-time employees, one of which is myself. My name's Nate Miller. I'm the founder. But I wanted to make sure I gave a shout out to the rest of the team here, Kristen, Trigby, Steve, and Andy, who are making all of these things that we'll be talking about today possible. And I think in many ways, the opportunity for being data-driven and leveraging these tools to their fullest potential really does allow us to do a lot of those kind of classic sayings and realize some of those classic, I guess, cliches now, doing more with less, working smarter, not harder, and so on. And I think the fact that a small team like ours is able to do so much with these tools, I think is really a demonstrator of how effective they can be in transforming businesses. So while we are a digital design consulting group, we're an agency. We work in kind of a very service-oriented type of capacity with many of our clients. We have introduced a new initiative in 2020. Early in 2020, we launched Proving Ground apps. We found that as our code base matured, we identified a few key tools that we thought would make for good standalone products. And PG apps really becomes the kind of mechanism for delivering those capabilities, and ideally allow us to deliver more impact at a larger scale and engage with stakeholders that we may not have been able to engage with before. Historically, I think Proving Ground is engaged with sort of a lot of larger companies that would be willing to bring on a consultant in different capacities. But when we look at the kind of the folks that are using our applications, including a lot of the open source ones, these are sole proprietors and small businesses and folks that are looking to just ramp up their digital capabilities at different scales, which we find it to be very, very exciting and a big opportunity for really pushing innovation forward. So the tools that I'll be talking about today are really addressing 3 objectives that in many ways provide a through line through a lot of the work that we do. The number one kind of area that we're interested in is reducing workflow friction. And oftentimes this friction is the result of moving data between design tools and oftentimes overcoming skills gaps, because a lot of the workflows that are out there do require more advanced skills in coding or computational design, knowledge of data platforms, and so on to achieve. And we're really aiming to lower that barrier to entry by reducing that friction. We're looking to introduce tools that integrate data in a way that matches the modeling freedom present in many popular design tools like Rhino. In many ways, we believe that data should be as easy to manipulate and integrate as it is to sculpt beautiful geometry. And finally, we're really looking and interested in this idea of insight and how business intelligence tools, data visualization, and so on can help us really unlock the underlying data of our building information model formats and more broadly our digital assets that we work with and produce every day. I think in many ways it's an unrealized opportunity right now to really use those digital assets to their fullest potential to gain insight and make more informed decisions. So in this webinar, I'm going to be covering some of the recent developments that surround three tools we've been making as part of PG Apps. The first one being Conveyor, which is a toolkit for Rhino-to-Revit interoperability and integration. And we're aiming this at kind of any skill level, not just the computation folks, but really anyone that knows how to kind of work a model in a way. Semantic is a tool for integrating and reporting Rhino-based data. So as you build up models, Semantic provides an interface for defining properties, layering in data sets, and reporting them out. And then Tracer is a toolkit for harvesting Revit information and combining it with business intelligence environments like Power BI. So these apps can be viewed as a response to a few things that we're seeing in the design and construction landscape. First, we want to create tools that build upon an existing foundation of platforms and software in wide use. Tools like Revit and Rhino and Power BI are already available to and in wide circulation among design and construction professionals. And by kind of building these applications with those tools in mind, we see an opportunity to really drive some impact with smarter workflows and data-driven methods. Secondly, we see an opportunity to offer simple solutions to traditionally complex problems. So again, going back to this idea of lowering that barrier to entry, appealing to individuals that might know how to direct model in Rhino and Revit and just need some nice standalone integrations without the intensive infrastructure or the need to kind of set up their workflow from the outset. We're hoping that a lot of the tools here are in many ways somewhat out of the box and can be readily applied. Third, we see these as gateway tools. We want to help build competency and skills with data among building design and construction professionals. I think anyone that has spent any amount of time in the building industry when it comes to digital skill sets recognizes that there are some serious gaps to fill. Not everyone can be a grasshopper expert or wizard. Not everyone can learn how to code. Not everyone is able to get into the models themselves and work with them. And so we're really hoping to kind of introduce these tools and hopefully level up kind of a generalized user base and also provide mechanisms by which building, business owners, executives, and managers can start to engage with data in new ways, while extending the ability for implementers and wizards to, computational wizards to leverage these tools as well. So by extending this ecosystem, providing value, and really building up these capabilities for a larger audience, we see these as these tools through PG Apps as being pretty powerful opportunities. So I'm going to go through each one and kind of address each toolkit and kind of where we're at, where we're going, and how these kind of start to really get to the core of being able to reduce friction, enable levels of insight, and integrate data in different ways. So I'm going to start with reducing friction. It's one of the subjects that's pretty near and dear to my heart. I don't think anyone on this call would say that today's workflows are in any ways frictionless. And when I talk about friction, I'm really talking about kind of moving data and geometry between applications, which can often be a painful experience. Over 10 years ago, I was at Acadia presenting a paper on some of the makeshift workflows and information file format exchanges that I was using as a designer on a stadium that I was designing at MBBJ, and it's kind of this tangled web of file format exchanges and data exchanges and so on. And even today, over 10 years later, we are seeing a lot of this cobweb and complexity still present, even as our capabilities advance. And along this journey with Proving Ground through various consulting engagements, we started to build up a toolkit that we referred to as Conveyor. We had kind of been engaging a number of projects these last 6 years, from the Lucas Museum of Narrative Art to the new Raiders Stadium in Las Vegas. And this toolkit really came out of this need to have more streamlined integrations between two platforms in particular, Rhino and Revit. We were driven by a couple of principles in kind of creating this toolkit and thinking about how workflows are being positioned. in the context of design and development here. The first is, we don't think that a user should need to know how to code or even use computational tools to execute a workflow successfully. This is a major barrier that many users experience, is that many of the workflow solutions out there today require users to know Grasshopper, they require users to know Dynamo, maybe even do a little scripting. And it's, and there are many talented and specialized folks out there that can do this. But it is limiting in the sense that we need to have capabilities that would allow someone that is just trying to get their model done in Rhino to have a pathway to get into Revit without sort of a lot of these prerequisites. So we wanted to kind of think about that in, first and foremost. We also understand that it's not a one-size-fits-all workflow. Our tools were developed over numerous project engagements that require very different considerations. Early stage interoperability is very different than trying to build level 300 models and workflows around those for construction. And so the ability to kind of have a flexible framework for working through these considerations is really important. And finally, we also recognize there are a variety of options out there for Rhino and Revit workflow tools, and we want to kind of think about Conveyor as a way to support those, which we'll talk about in some of the new developments. But for a little context, I wanted to provide a bit of background on what the current version of Conveyor lets you do. Essentially, it is an importing framework that lets you take a Rhino model, assign classifications to the objects that you may model in Rhino, and then import them into Rhino using OpenNURBS. OpenNURBS is the foundation of the Rhino file format. It is open, it is extensible, it's really powerful, and it allows you to build translators on top of, even if you happen to have Rhino or not, which makes it kind of very flexible. And so the way that this works is that we are in effect building on top of OpenNURBS and creating a direct connection into Revit. So I'm able to like hook into a Rhino file and bring in objects as I need them. And what that starts to look like is something like this. So in Rhino, you're able to kind of model anything, right? You can kind of model any surface, shape, volume. You can define blocks. You can work with meshes. In Rhino 7, you can work with sub-D models. It's almost this, I often call it the Swiss Army knife of design tools. It's immensely flexible and powerful. And what Conveyor does is it hooks into those files and provides a user with a Rhino interface for selectively importing different objects and classifying them as their requisite Revit element. So here you can start to see sort of this mirroring of data across these different platforms. By reaching into the Rhino file, we're able to pull a block in and create it as a family. We can grab a mesh and create a very kind of clean hidden edge representation of that mesh as a family as well. We can bring in native floors, levels, grids, and so on through this import framework. None of it requires knowledge of Grasshopper or coding. It's just kind of all built into this interface. And what makes this, we think, pretty powerful as a kind of a version 1 is that folks that are adopting this are perhaps already up to speed on Rhino 6. So this supports Rhino 6 files. It also supports Rhino 7 files, since Rhino 7 has now been released commercially. So this import workflow is kind of all part of that ecosystem. It allows you to work outside of Revit. You kind of are working in Rhino as a standalone modeling environment, preparing your data, preparing your objects, and then as you need to bring them into the Revit environment, which makes sense for a lot of workflows. A lot of our clients and customers oftentimes will receive a Rhino model from an external party, and they need to bring it in without necessarily getting into the Rhino file. This type of workflow kind of allows us to expand on that. It's also extremely efficient with the Rhino licensing, thanks to OpenNURBS. It doesn't necessarily draw a Rhino license for every operation. It uses that kind of open file format as a way to kind of pull objects in and directly translate them. But this workflow is not the only workflow that we are supporting. And as we go into the future versions of Conveyor, we're excited to announce kind of a new level of integration between these environments. I just want to do a gut check. Is everyone still seeing my screen okay?
Yep, you're doing just fine, Nate.
Great, awesome. Just wanted to make sure. I can sometimes build up a head of steam and forget that there's actually other people on the call. So we're kind of working towards a new version of Conveyor that not only kind of maintains this idea of being able to import Rhino files through OpenNurbs using this type of workflow that I just described, but we're also looking at new paradigms that are being introduced in Rhino 7. Many folks on this call may be familiar with the new capability of Rhino 7 called Rhino Inside. Rhino Inside allows for us to really think about more bi-directional integration and more direct interaction between our Conveyor translators and the Revit environment. So for those of you who may not be familiar with Rhino Inside, it basically allows Rhino to behave like a plugin to other applications. So you can directly access Rhino capabilities within a parent application like Revit. You're able to find within Rhino 7 a free download for Rhino Inside Revit. Basically allows you to open up Rhino inside of the Revit environment and kind of do stuff with Grasshopper. They have a rather extensive toolkit for Grasshopper for doing different things on top of a Revit file. In many ways, we kind of joke that it's kind of an alternative to Dynamo, kind of providing Revit with another kind of computational design interface. And while this is extremely powerful, this toolkit can be very overwhelming for users that may not know computational design and may be interested in, it may need to have that lower barrier to entry. And so what we're doing with Conveyor is we're basically building and allowing Conveyor to operate as a plugin to Rhino Inside. And instead of a horizontal arrangement of importing objects, Conveyor can act as basically a plugin to this vertical stack, wherein if you're launching Rhino Inside Revit, you can access the Conveyor tools and user interfaces and have a more direct data exchange between these environments. So we're kind of very much directly building on this available capability and really thinking about what it means to equip a user with our toolkit alongside these other kind of paradigms that are being introduced. So how does this work in practice? So this is a clip that starts to suggest kind of one opportunity. A user is able to launch Rhino, access the Conveyor toolbar, select an object, and send it into Revit. No need to interact with Grasshopper. No need to work with kind of a collection of nodes. A simple single-click selection of an object and importing it into the environment. And if I think back 11 years ago when we were doing work on the Hangzhou Stadium at MBBJ, this type of workflow would have saved me days of time. Probably given the length of that project, we could probably think about it in terms of weeks of saved time, just kind of allow this type of integration to happen. And here it's, again, leveraging that framework and cutting past the spaghetti, providing a user with the ability to say, hey, I want this object in Revit. This is a sub-D object, which is also pretty interesting. It's a new Rhino 7 object type, which here we're kind of bringing in and using some of our novel mesh processing to produce some very kind of clean hidden edge representation of the object that can be used in backgrounds of documentation and so on. This also allows us to go the other way and think about ways with which, if you were to launch our Conveyor toolkit through the Rhino Inside framework, we can connect into the file and say, hey, get these objects from Revit and put them in my Rhino model so I can have them as a reference. So here I'm selecting a set of rooms and I'm saying, okay, get all the room volumes and push them into Rhino and grab a roof, for example, pull that in. And then we're also able to kind of support things like topography and other landscape objects, just to have them be brought directly into the Rhino environment. Again, kind of bypassing some of the kind of overhead of getting into Grasshopper, and again, using our kind of novel translation framework to do this. So when we think about the type of kind of future versions that we're working towards, our framework is supporting both modes of interaction. In version 1, we had what we're kind of we're calling now kind of outside mode, wherein you're able to still import external Rhino files and bring them through the sort of classification and translation framework into Revit. And then when activated through Rhino Inside, our tools then provide another layer of user interface that can allow for the exchange of data. An exchange of data from Rhino to Revit in kind of more of an integrated manner. So on one hand, we're offering interoperability. On the other hand, we're offering direct integration. So it's important to also think that Conveyor itself, we're not offering, it's a new tool that's been put out there. In 2020, we started selling V1 as a product that people could download and integrate within Rhino 6 and 7. We're now moving towards the release of a new version that will be a couple of steps up from V1. So as a point of comparison, right now you can buy V1 off of our website, and we can also we're also planning to launch V2 in spring of 2021 at a slightly different price point. This is inclusive, the pricing here is inclusive of only the Conveyor tools. I'll be talking about Semantic and so on soon. If you are a V1 customer, there will be an upgrade path. And in fact, if you were to buy V1 of Conveyor today and upgrade, that's actually going to be, we're thinking of that as actually being kind of more economical for folks than if you were to, wait for V2 and buy that. So there is we're really trying to support folks that are really elevating our game and bringing us forward. So we'll be posting some of this information on pricing here very soon. Maybe we can cover it at the end in case you missed the slide. I should also note that if you're a student and educator, I'll be talking about our educational program. If you're a student or educator, there's a massive discount that we give to students, and any upgrade on these tools is free. So we'll be talking about that. The next thing I wanted to talk about is how we're integrating data within Rhino specifically. What we're finding is that tools like Revit, and we've experienced this and hear this all the time, they have very mature data structures if you're in a building information modeling environment. But a lot of those data structures can be really inflexible at early stages. Sometimes we don't know what an object is going to be, and sometimes we need to kind of be more agile with our data structures. Meanwhile, we have Rhino, which is kind of a model anything approach. But if you're wanting to do really sophisticated things with Grasshopper or with Rhino, you kind of have to know Grasshopper, you know, a little scripting. There's some data entry and component kind of capability with Rhino 6 and 7, but we really wanted to kind of think about a more kind of sophisticated way of integrating data and leveraging it. So Semantic was developed as a framework that allowed us to organize as consultants data within Rhino, and it was really born out of a confluence of several engagements that we had with fabricators and designers, where kind of metadata on objects was really important. And so this interface is all about kind of being able to define data structures for your objects and have them really complement the kind of freeform nature of Rhino. A couple of things that we wanted to kind of use as guideposts for the development of this is that we also kind of believe, going back to some of our initial guideposts on Conveyor, is that the user shouldn't necessarily need to know computational skills or coding in order to integrate data with their objects. We want users to also be able to think about flexible data structures that they can integrate within any design stage. So Semantic has certain use cases in fabrication stages, as well as early stage, planning is one of the considerations here. We're also using data structures that should be flexible. So not every project may have the same data structures, and not every object or every project may need the same data structure. So we're kind of creating kind of a bit more of an open-ended framework here for how we're developing it. Diagrammatically, it looks like this. Semantic is a plugin for Rhino. It exposes an interface for metadata assignment and allocation. All the data is stored within open NURBS. the Rhino file 3DM format, at which point it can be leveraged in other contexts. We can bring the data points in through Revit using tools like Conveyor, or we can hook a Rhino file into a business intelligence environment like Power BI to get going. I should note that if anyone has any comments or questions, feel free to put them into the question and answer bar on Zoom, or type them in the chat. We'll kind of be perusing the chat, and Steve will also be responding as we go. We'll be kind of doing a more interactive Q&A towards the end of this, by the way. I'm going to kind of try to save that to the end just so we can get through the content, but please expect a discussion here soon. So how does this work? Semantic is kind of conceived of as a stockable window that allows a user to define a collection of properties and assign them to objects as metadata. We can create a collection of object properties, have different properties exposed as drop-down menus, as cost values, numeric parameters. We can expose slider interfaces. We can also expose kind of more categorical Boolean pieces. So you're basically building up a property set that exposes itself as a user interface within Rhino. This allows us to kind of do some really fun things. So if you've built up a Rhino model that represents a facade or any kind of surface, we can click on that object and access the different data objects that one has and have assigned to it. That may be kind of custom defined for a specific project, a specific activity, and so on. Here, we're kind of suggesting that, hey, maybe for this model with the facade, we need to be able to classify facade identifiers for the different paneling components, maybe the orientation, north, south, east, west, maybe a schedule for installation. You can also see in this slide that we have some project information that's been defined at the document level, that this is a particular job, it has a job number and a budget to it. So this is, and it doesn't change anything about how someone might model their Rhino object. It's simply about assigning this kind of important metadata that may want to follow a model object through the production process. What this also allows us to do is then think about how this data can be reported out to a user. So Semantic is not only about property assignment and manipulation of those properties, but we can also report out the data in the form of tabular information, not so unlike schedules in Revit. So here you're seeing that as I'm kind of manipulating and changing up a few properties on a set of very conceptual floor surfaces, we're also kind of being able to see the kind of output and changing of the report, the tabular report schedule, in this case, reporting things such as cost and square area. When combined with kind of a workflow that may even use Grasshopper or maybe even using just straight modeling, as I go through this animation, you can see that as I'm selecting objects and changing their properties, the schedules are changing. In the background, we're using our free and open source Conduit plugin to project live graphs and charts that are kind of communicating some of the underlying semantic data that's been assigned to these objects and pushing them forward. So we're able to kind of complement more kind of direct modeling, manual modeling efforts with these kind of data feedback loops. I often joke that what I don't want to see anymore are designers running the area command on objects and tabulating things with calculators, which happens more often than we would like to see happen in practice, but it's still very much the case. This kind of bypasses a lot of that. You can start to do takeoffs much more quickly. But where there's another upside to this is that as we start thinking about how data can become integrated into our modeling environments like Rhino, these models can become assets that are used in the presentation process and perhaps be combined within environments that allow you to create dashboards or interactive reports with this three-dimensional data. So the Semantic, we've started to package online our Semantic plugin with a new Power BI visual that allows you to visualize Rhino models inside of Power BI. For those of you who aren't familiar with Power BI, it's a Microsoft business intelligence tool that lets you build interactive dashboards. It's a no-code environment. You can build up charts, interactive charts and graphs and things like that through drag and drop interfaces. And a lot of times it's used in the context of accounting or big data analytics. And since we think that models and digital design models produced by architects and builders are data, we think that these should have a place inside of this space of business intelligence. So we've created our own Rhino visuals that allow us to load up Rhino models in the Power BI environment and cross-reference them with data points that allow us to kind of visualize different components. So here you can see I'm rendering that same kind of sectional model that I had in Rhino. It's being rendered inside of the Power BI environment. I'm able to drag and drop properties onto it and override colors to get different data visualizations. These visuals are WebGL 2.0 compatible, which means that these dashboards can be rendered in the browser as well and shared with others. And so what that starts to look like is your user is able to start to build up interactive three-dimensional reports tied with other visualizations like bar charts, pie charts, slicers, and filters using Power BI, publish them to the web, and share them with others without needing to write a single line of code to get it to happen, which we think is an extremely powerful advancement in this type of scenario. So presently, Semantic V1 is available for purchase on the website. We're preparing various service releases to customers throughout the year. It allows users to have access to the Semantic plugin for Rhino as well as the Rhino Power BI visual. One thing I did want to note about licensing on all of these products is that these are perpetual license prices. They can be installed on up to 2 devices at a time, as well be transferred between different computers and devices if you so choose. So these aren't subscriptions; these are one cost. And of course, if you want upgrades and things like that as they come, you're free to choose it, but you don't lose access to the previous tools. So the last section I wanted to talk about is kind of building on some of these explorations with Semantic, where we're rendering three-dimensional Rhino geometry in places like Power BI and pushing them to the browser and creating these interactive reports. We wanted to think about the same kind of ideas related to BIM project data. And one of our observations as consultants is that architects and builders are sitting on very large quantities of data. And that's often locked away inside of proprietary files. Maybe they end up in an archive disk drive somewhere. And what we want to do is think about ways with which we can start to unlock that underlying information and create kind of standalone ways with which these data points can be accessed and built upon. And that's where Tracer comes in. Tracer is a standalone data harvesting application for transforming the data stored within a Revit file into an open relational database that can be queried externally. And it builds on some of the work that we've been doing with data centralization engagements, where we have database servers and so on. What we're doing with Tracer is we're creating a self-contained version of being able to create standalone database files that don't require any kind of infrastructure to take advantage of them and start to leverage them. So a couple of principles that we're starting from is that users that need to access their BIM data shouldn't necessarily need to be analysts or coders to get into it. We also think that if it's in the model, it can be in a dashboard, and there should be a very clear path to getting it to that point. And that also 2D and 3D data should be part of this conversation and should be, of course, shareable with others. So the way that we're achieving this is that the Tracer product includes a harvester for Revit. It scrapes the model and creates a open relational database file using SQLite. It's a public domain database file that you can access the contents of using, if you're really into the data analytics side, standard query language and so on, but you don't necessarily need to know that for this. Just know that we're creating this file as something that a business intelligence environment like Power BI can hook into. So in an overall workflow, the steps that one takes is that you're able to go from a model. You can start to select different categories. This is something that is new that we're introducing, and I'll be talking about that as well. We're able to select different categories. We're now able to choose to select 2D or 3D exports of element geometry and push them out. So what you can get today is essentially what's on our website is the 2D version. We're able to get every element and parameter sets from a Revit file, kick those out to a database file that can be hooked in through Power BI to build a dashboard. And again, we're kind of operating by these principles of drag and drop. If we're able to get access to the data, we should be able to dynamically create visualizations in Power BI based on that data. So here we're looking at a very popular use case that we see for Power BI, right? Is kind of rendering of space plans. And we've observed many firms adopt very time-intensive workflows and processes to render space diagrams in Power BI. It usually involves manual tracing, the use of vector files, and if you have any kind of change that's made to your kind of plan, you have to kind of really go through this process of manually updating it. Here, what we're saying is that a plan geometry should be treated, and kind of two-dimensional geometry, object geometry should be treated the same as any other data point. So numeric data, text data, spatial data. And so as we kind of drag and drop object location information into our visual, it automatically renders and draws the information and allows us to perform overrides of color coordination and tooltips and so on. And so in a matter of a couple of steps, exporting, connecting, and visualizing it, you have interactive space plans, which has kind of some real benefit when it comes to preparing different presentable ideas from building information models. So this is an example dashboard that's been published from Power BI to the Power BI cloud. Rendered in the browser, we see a spatial diagram of a kind of an office leasing diagram combined with leasing information about costs and occupancy, all rendered in the browser. And the dashboard was, again, composed without the need to code, use HTML to define the dashboard. It's all using kind of Power BI's engine with our visual to let it happen. We're now applying the same kind of idea to 3D, wherein, building upon our work with Semantic, we're now rendering three-dimensional Revit objects, and this is kind of coming soon this spring, a toolkit called Tracer 3D, which is a step up from the kind of current capability. And instead of rendering two-dimensional information, we're exposing a new visual for rendering three-dimensional data. So again, the drag and drop interface allows us to pull in specific element types and object geometry so we can see and visualize these objects inside of the Power BI environment, cross-reference it with other data, navigate the model using conventional modeling navigation techniques, scroll, zoom, pan, and so on, with it all tied in with your dashboard. And this becomes really powerful when you think about different use cases for it. We might think about a way to perhaps present a core and shell to a client. Here we have an example of a dashboard communicating core and shell information. We might want to create a dashboard that looks at three-dimensional room geometry and the relationships between blocking and stacking diagrams with Power BI. Maybe we're interested in kind of structural components. These are some of the kind of structural geometries harvested out of a Revit file sample project. And also mechanical is another use case wherein we're getting access to ducts and equipment and other fixtures that exist in the kind of MEP space. So these are all kind of harvested extracts out of Revit files and then presented through a dashboard combined with the data and the properties that these objects have as well, and not just the geometry. So presently, Tracer 2D is available for download. You get the Harvest add-in and the Power BI visual for 2D. We will be rolling out the new 3D visual where you'll get both 2D and 3D at the same time. And there is an upgrade path for this. So if you've invested in the 2D visual, there is an upgrade to get the 3D version. It, again, as with Conveyor, it actually ends up being cheaper for the user to buy 2D and then upgrade than it does to buy 3D outright when that becomes available. Just kind of to support our existing customers. I should also note that when it comes to some of the new interface design on the harvester, all of our 2D customers will be getting access to kind of a new harvesting add-in that allows one to select different category sets and make kind of specific changes. So existing customers can expect an update from us through a service release if you've at no cost for some of these tools. And of course, students and educators can upgrade for free. We do have enterprise customers that are kind of on more of a recurring annual subscription for very larger pools of users. And I should note that all of these tools, if you're kind of set up with us through an enterprise plan, automatically get access to these tools as part of that. So what's next? I wanted to just quickly talk through a couple of ideas on what you can do to engage and learn more about some of what we've talked about. We have a website up. We can visit our site and learn more about some of the products that are currently available. And the site will, of course, be updated as we start to roll out some of these new items in the spring of 2021. We have a lot of documentation for these products. So if you have a question on how to do a certain workflow, our site has links to documentation, how-tos, video tutorials. We've invested a lot of time in curating these tools or in these resources for folks to be able to learn how to use the plugins. We also have educational programs for students, professors, and researchers. Essentially, what this comes out to be is if you're at an institution studying to be an architect, working towards your PhD, you're in the building sciences, you're a professor, you essentially get a 93% discount on everything, and you're able to access all of these tools for a very economical price. I think it tends to be $77 for students to get access to all tools. And upgrades are free for students and educators as well. So we really want to support the educational community here. And of course, what I like to do is encourage you to reach out to me directly. I have an email address here if you'd like to ask me personally. My name is Nate Miller. Any questions about these tools, feel free to reach out. I'd like to hear from you and talk about what these tools can do, talk about if you're kind of a bigger firm that needs to support a larger pool of users, willing to work with you on how that can work. So feel free to get in touch. So thanks everybody. I know that there's been some high activity in the chat. So what I'm going to do is go through a Q&A process with the time remaining. We have about 15 minutes left, so maybe we can cover some good territory.
Nate, I've copied some of these questions. Should we start on Conveyor questions?
Yeah, let's start there.
Cool. So there were some questions from Kyle and Chris about the transfer of materials. Can you talk about how that works maybe on V2 in terms of going into Revit from Rhino and from Rhino-to-Revit? Is
Absolutely.
there two-way materials, and how does that work?
Absolutely. So presently, our solution to materials is if you have a material that's assigned to an object or to an object layer, and you perform say a translation to, let's say it's a surface, right? And the surface is going to end up in Revit as a family. What Conveyor will do is it will find the materials that have been assigned. It will look up inside of your Revit file for a matching material. And if it finds it, then it will assign it to your object. So you can start to establish some level of parity between the Rhino environment that you're working with and the Revit materials that may be available. If there isn't a match found, what the object does do in any event is it exposes a material parameter that one can override and change manually on the object. Where this becomes really powerful is with some of our block translation workflows. And you can find, we have a couple of video tutorials on this and demonstrators that show this. So if you have a block that's made up of, say a dozen different objects, and each of those objects has, a different material in Rhino assigned, what Conveyor will do is it'll process that block as a family and expose the material properties for each of those materials that are found in that object. So user can override them, or if you have a matching library in Revit, it will automatically assign. So materials are supported. Certain element types, like meshes, can't receive materials in Revit, so that's kind of a non-starter in that case. But we are striving, especially when it comes to solid objects and blocks, to really expose ways with which users can control materials. Yes.
Great. There was another question about that linking when you go from Rhino to Revit and in V2 Revit to Rhino. Can you talk about how the elements are tagged? Is metadata passed through, and things like updating?
Yes, absolutely. So this is the case both in the direct integration and the importing framework. We are tracking, whenever you bring an object into Revit through Conveyor, it gets tagged with the source geometry, the source Rhino ID that comes from Rhino, so we can trace the source of the object back to Rhino. We're also performing what we call a kind of a memory hashing on the object. So we're able to kind of identify whether or not geometry from one environment to another has changed. So if, for example, you've created a block inside of or a mesh or a floor inside of the Rhino environment, Conveyor will do a comparison with objects inside of Revit and find which objects have changed in terms of its geometric composition and recommend an update to the user. So what it's able to do is say, like, hey, these 10 objects are different. Do you want to bring in the updated version? And so on. And the integration approach also works the same way when it comes to updating. So it makes things really straightforward when you're trying to, update a bunch of levels or, change up things. There are certain aspects of Revit that don't allow direct object updating, and instead you have to like delete and replace. Some of that stuff you simply can't overcome. But in what we have done with our documentation is that we've, with the documentation that's on our site, is described, what specific things are happening for each element type as it comes over, so the user can be informed by some of that.
Pete asked a question about when translating Rhino to Revit, does Conveyor create native Revit geometry, roofs, adaptive components, or is it importing direct shapes?
It's a mix. There's actually a couple of options for different conditions. So with floors, it's bringing in the floor. And you can edit it as a floor with floor openings after it's been imported in. Levels come in as levels, grids come in as grids, and so on. When it comes to solid shapes and say block families, what that does is what our translation workflow does is it brings in the geometry into a family, and it generates native Revit geometry from that. They're called freeform elements. That in fact can be edited after the fact. They can receive materials and so on. What that means is that, if you're, say for example, you have a kind of a complex object and you bring it through Conveyor, it'll create the family and generate it. We also do expose a direct shape option. Direct shapes tend to be faster to instantiate, but they are far more picky when it comes to certain geometry types than some of the translation workflows that we've implemented as part of our toolkit. So we have found, for example, that, I'm going to try it as direct shape. This really complex object doesn't generate as a direct shape, but it will generate as a native family that we're kind of using through some of our logic. So we're trying to expose as much choice as possible. If someone needs something quick and dirty, or something needs kind of a more reliable object. It's a complex question. It seems like a simple question, but we have, the conveyor exposes a number of different pathways for those considerations.
And then in Conveyor is subcategories supported?
Yes. So subcategories are generated inside of the object. It's driven by the layer that an object exists on as one step. It may also be that your object has a subcategory defined in some of Conveyor's metadata fields, and those will be generated if they're present as well. So yes, when you bring your objects in, say you want to translate a block into a family, that will carry over not only the materials, or if it can't find a material, at least expose the material parameters. And it will also take in and bring over layer information and expose subcategories, which really helps with filtering your information for documentation.
We had some really good questions about Semantic. A couple people are asking for an API or an SDK for added custom functionality, or even being able to sort of pass data to objects without using the Semantic panel. Is that possible currently?
So we do have, it's not entirely documented, but Semantic does have a DLL that one can build on and extend with the Semantic framework. Unfortunately, it's not in a spot where it's extremely user-friendly to use, but it is possible. Beyond that, we do provide and expose Grasshopper tools for the Semantic data, which we tend to use a lot. So for example, if we wanted to kind of assign a bunch of data, push it into Grasshopper, compute some stuff, and send it back into some fields, Grasshopper does enable that. At the end of the day, there's nothing super, I would say, proprietary about or hidden about where the semantic properties go. It's essentially, stored in, a Rhino object's, user text. So if you want to get, text from an object, it will kind of, expose the available properties. Although we do have kind of a more novel dictionary and GUID approach to how we kind of key an object property to its value and so on. But yeah, some of the there are Semantic comes with DLLs that could theoretically be used as kind of an API.
Great. So there's some questions about Tracer as well.
Okay.
Bill was asking about MEP objects in their sort of insane amount of polygons. When sort of translating things into 3D, how does that process work? And is there some compression or maybe some quality issues that gets taken care of so that the model is kind of easy to move around in?
It works really well. Maybe I'll just leave it at that. No.
It's the magic that we just can't talk about.
No, it's a good question. So when it comes to rendering highly complex objects in Power BI, there are a couple of things to consider. We discovered the limit with which there's actually a limit on how much data you can actually store in a Power BI field. So we have implemented some compression algorithms that will post-process, complex Revit meshes into something that can be more readily stored in our database environment. Of course, compression comes with kind of time to harvest, impacts time to harvest and things like that. But we have managed to harvest some rather large models and get those displayed. We're just in the process of rolling out 3-dimensional capability. So we're currently vetting kind of the upper limit on how things are progressing there. But we've been fairly encouraged by some of the models we've been pushing through and seeing some of the objects. Now, of course, we're rendering this stuff using in Power BI using WebGL technology. We're using the mesh directly, and if you have a lot and a ton of really complex geometry, you can imagine that we'll take a performance hit on your frames per second. But we've been pretty encouraged so far by the amount of data that we've been visualizing and how it performs within Power BI environment. In fact, we often joke that these days, as we've been pushing stuff into Power BI, that Power BI tends to allow you to navigate a Revit model more freely and fluidly than Revit itself, which is kind of a kind of funny. Is Power BI
bonus added feature?
Yeah, is Power BI a better building information modeler than Revit? We're still evaluating.
So to touch on Marco's question, is it possible to hide objects dynamically? I think one thing that Nate demonstrated in the tracer videos was using slicers and interacting with bar charts and changing the geometry that's shown in the 3D visual, for example, or even the rooms that are shown. That's the whole, that's a great use of that visual in Power BI, is to dynamically sort of highlight specific elements or groups of spaces and things like that. It looks like there were some other questions I didn't touch on with Semantic. There was one question about, for data assignments, can IFC be used?
So IFC, we're not doing anything explicitly with IFC. We're working directly with the OpenNURBS file format and how it uses user dictionaries and user text to assign data. We're not doing anything explicitly with that file format, although we've used IFC from time to time. It may be really interesting to kind of test out in kind of maybe a future release is, can we, essentially serialize semantic properties as IFC data? I'm sure like tools like, Grasshopper tools like Geometry Gem and some of the work that John Merschen's been doing would likely allow for a lot of that to happen. But we're not at this point doing anything explicitly with IFC. We're kind of focused on kind of just working the OpenNURBS file format at this moment.
Back to Conveyor, there were some specific questions about other Rhino plugins like Visual Arc. You familiar with that one, Nate? Does Conveyor work with Visual Arc and other Rhino plugins?
It should. I mean, Visual Arc is it's a really cool plugin. It's, essentially, for folks that are on the call that don't really know about it, it's it's kind of like a building information modeling layer on top of Rhino. So, a wall is a wall, and you can do, things like placing doors and, building up some rather cool assemblies that are, one, IFC compatible, as well as, ways that you can start to get some documentation out of Rhino, which building kind of style documentation out of Rhino. So I don't know that I'd be kind of interested to hear from some of our customers that may be trying Semantic or using it, if they're using it in combination with Visual Arc. I'm not a Visual Arc user, so I don't quite know what the ins and outs of such a workflow would be, but I would imagine that a Rhino object that has a, that is kind of built in Visual Arc could have semantic data assigned to it. But that's not a, that's not a guarantee.
So I see we're right at about time. There were some questions, Mayur and Phil, if you want to follow up with us. Nate had his email address up here on the screen. We'd be happy to reach back out and work through some of these other more detailed questions.
Yeah, sure. If you have any kind of technical questions about the tools or like to know more, you are more than welcome to reach out. I'll put my email address on the screen again. If I can find my window here, because I've got like a bunch of windows open. Let's see.
And there were some questions about how to get access to this recording.
Yeah. So this recording will be posted on YouTube. So you can expect to see you can expect to see this posted on YouTube, and we'll of course be circulating around social media as well. Let me see if I can get to our slide here. Pardon me. There we go. So again, if you have any questions, feel free to reach out to me through nathan@provingground.io. And so, yeah, thanks everyone for joining. We had a great turnout today, and hopefully this is valuable and useful, and that you're interested in knowing more about these tools. And we hope ultimately that they're delivering value. We really believe in this toolkit, and think that from what we've seen and even experience, we use these tools ourselves pretty regularly just in our work. And we think they fill a very important niche and can really help extend the capability of a team. So thank you so much.